The third method to analyze the modes is to use the time view. The time is essentially the plotting of flight parameters versus time. In the longitudinal direction, the parameters are the horizontal speed, the vertical speed, or rather the fluctuation in the horizontal direction and vertical direction compared to steady horizontal flight, the pitch rate, and the pitch angle. So for instance, let's look first at the modal response, the time behavior of a mode. We are looking at mode 1, which should be the short period mode in our case. We'll plot a graph with increments of 0.1 seconds and for a total time of 10 seconds, and let's add a curve. So this is indeed the short period mode, and we see this because it starts at a certain level and it returns very, very quickly to 0. Now let's zoom in by changing the values here. Let's put in a smaller increment, 1 millisecond, and let's run this only for 0.1 second and recalculate the curve. Right, we see now that this curve, we have zoomed in on the between 0 and 0.1 second, and we can see more in detail how quickly it goes back to 0. So this is the heavily damped mode, the short period mode. Let's look at mode 3 and recalc here. Well, it's a slow mode, so in the time between 0 and 0.1 second, it doesn't change much. We need to plot it on a bigger scale, so for 10 seconds, but by increments of 0.1 second should be enough. Let's recalc the curve, and this is the fugoid mode. We see that the horizontal flight, or the flight, the perturbation to the horizontal speed in plane axis fluctuates from 1 plus or minus 1 meters per second. This is the normalization, it's been normalized to 1. If the speed fluctuates by 1 meters per second in the x direction, in the z direction it will fluctuate by 0.02 meters per second. The pitch rate will be this, and the angle will be this versus time. If we plot it on a longer time, for instance 50 seconds, let's do that, we see that it's very, very, very slightly divergent, which is not really meaningful. It's we're just reaching the limits of the calculation. The fugoid is not much damped in the case of my plane here. Let's look at the lateral direction now and look at mode 1, which was the roll damping. So let's plot it on a scale of 1 second by increments of 0.1 second. And there we are. It goes back very, very fast to 0. So the increment is a bit too coarse. We only have 2 points between 0 and 0.2. Let's decrease this by 0.01 second, recalculate the curve, and there we have a smooth curve. This curve goes back to 0 quite fast. Modes 2 and 3 will be the Dutch roll. Let's have a look at them. So it looks like fugoid, but this time it's more damped than a fugoid. The perturbation to lateral velocity in the y direction, it's normalized to 1 as a starting value, and it goes back slowly to 0. So do the roll and yaw rates, and so does the bank angle. So this is the behavior of the Dutch roll versus time. You could also plot this kind of curve for an initial condition response in the longitudinal direction. So let's imagine we have a gust of wind which pushes our plane upwards by 1 meter per second, and here we have the response to this gust of wind. More complex, a bit experimental, you can define the full load versus time here and see how the plane responds.